validity and reliability. Validity and reliability issues in research focuses on the quality of measures and enables us to consider whether we are studying what we think we are studying and whether the measures we use are consistent. Subject: concepts, validity, types of validity, reliability and types of reliability. We often think of reliability and validity as separate ideas, but in fact they are related to each other. One of the favorite metaphors for the relationship between reliability and validity is that of the target. Think of the center of a target as a concept that you are trying to measure. Imagine that for each person you are measuring, you are taking a shot at the target. If you measure the concept perfectly for a person, you are hitting the center of the target. If you don't, you are missing the center. The more you are off for that person, the farther you are from the center. This figure shows 4 possible situations. The first one, you are hitting the target consistently, but you are missing the center of the target. That is, you are consistently and systematically measuring the wrong value for all respondents. This measure is reliable but not valid. The second shows hits that are randomly spread across the target. You seldom hit the center of the target, but on an average you are getting the right answer for the group. In this case, you get a valid group estimate, but you are inconsistent. Here you can clearly see that reliability is directly related to the variability of your measure. The third scenario shows a case where your hits are spread across the target towards one side and you are consistently missing the center. Your measure in this case is neither reliable nor valid. Finally, we see the Robin Hood scenario. You consistently hit the center of the target. Your measure is both reliable and valid. Validity. Validity refers to the degree to which a study accurately reflects or assesses the specific concept that the researcher is attempting to measure, while reliability is concerned with the accuracy of the actual measuring instrument or procedure. Validity is concerned with the study's success at measuring what the researchers set out to measure. Researchers should be concerned with both external and internal validity. External validity refers to the extent to which the results of a study are generalizable or transferable. Internal validity refers to the rigor with which the study was conducted and the extent to which the designers of a study have taken into account alternative explanations for any causal relationships they explore. In studies that do not explore causal relationships, only the first of these definitions should be considered when assessing internal validity. Let us look at an example. Many recreational activities of college students involve driving bikes. A researcher wanting to measure whether recreational activities have a negative effect on grade point average in semester exam might conduct a survey asking how many students drive to school and then attempt to find a correlation between these two factors. Because many students might use their bikes for purposes other than or in addition to recreation, this research study might prove invalid. Even if a strong correlation was found between driving and grade point average, driving to college in and of itself would seem to be an invalid measure of recreational activity. Measurement procedures that measured family size by recording the number of people in a dwelling unit would be less valid to the extent that paying guests, visitors and domestic help are not identified and eliminated from the count. Type of validity. Face validity. Face validity is concerned with how a measure or procedure appears. Does it seem like a reasonable way to gain the information the researchers are attempting to obtain? Does it seem well designed? Does it seem as though it will work reliably? Unlike content validity, face validity does not depend on established theories of support. Unlike content validity, face validity does not depend on established theories for support. Criterion related validity or predictive validity. Criterion related validity, also referred to as instrumental validity, is used to demonstrate the accuracy of a measure or procedure by comparing it with another measure or procedure which has been demonstrated to be valid. For example, imagine a hands-on driving test has been shown to be an accurate test of driving skills. By comparing the scores on the written driving test with scores from the hands-on driving test, the written test can be validated by using a criterion related strategy in which the hands-on driving test is compared to. Let's move to construct validity. Construct validity seeks agreement between a theoretical concept and a specific measuring device or procedure. For example, a researcher inventing a new IQ test might spend a great deal of time attempting to define intelligence in order to reach an acceptable level of construct validity. Construct validity can be broken down into two subcategories: convergent validity and discriminate validity. Convergent validity is the actual general agreement among ratings. Discriminate validity is the lack of relationship among measures which theoretically should not be related. To understand whether a piece of research is construct validity, three steps should be followed. First, the theoretical relationships must be specified. Second, the empirical relationships between the measures of the concepts must be examined. Third, the empirical evidence must be interpreted in terms of how it clarifies the construct validity of a particular measure being tested. Content validity. Content validity is based on the extent to which a measurement reflects the specific intended domain of the content. Content validity is illustrated using the following examples. Researchers aim to study mathematical learning and create a survey to test for mathematical skill. If these researchers only tested for multiplication and then drew conclusions from that survey, their study would not show content validity because it excludes other mathematical functions. Although the establishment of content validity for placement type exams seem relatively straightforward, the process becomes more complex as it moves into the more abstract domain of socio-cultural studies. For example, a researcher needing to measure an attitude like self-esteem must decide what constitutes a relevant domain of content for that attitude. For socio-cultural studies, content validity forces the researcher to define the very domains they are attempting to study. Reliability. Reliability is the extent to which an experiment, test or any measuring procedure yields the same results on repeated trials. Without the agreement of independent observers able to replicate research procedures or the ability to use research tools and procedures that yield consistent measurements, researchers would be unable to satisfactorily draw conclusions, formulate theories or make claims about the generalizability of their research. In addition to its important role in research, reliability is critical for many parts of our lives, including manufacturing, medicine, sports, etc. An example of the importance of reliability is the use of measuring devices in Olympic track and field events. For the vast majority of people, ordinary measuring rulers and their degree of accuracy are reliable enough. However, for an Olympic event such as the discus throw, the slightest variation in measuring device, whether it is a tape, clock or other device, could mean the difference between the gold and silver medals. Additionally, it could mean the difference between a new world record and outright failure to qualify for an event. Olympic measuring devices then must be reliable from one throw or race to another and from one competition to another. They must also be reliable when used in different parts of the world, as temperature, air pressure, humidity, interpretation or other variables might affect their readings. A classic example of an unreliable measurement instrument would be an elastic measuring tape, which would be likely not to give the same reading upon repeated measurements of the same object. Types of reliability. Equivalency reliability is determined by relating two sets of test scores to one another to highlight the degree of relationship or association. In quantitative studies, and particularly in experimental studies, a correlation coefficient, statistically referred to as R, is used to show the strength of the correlation between a dependent variable and one or more independent variables, which are manipulated to determine effects on the dependent variable. An important consideration is that equivalency reliability is concerned with correlational, not causal relationships. For example, a researcher studying university English department students happened to notice that when some students were studying for finals, their holiday shopping began. Intrigued by this, the researcher attempted to observe how often or to what degree these two behaviors co-occurred throughout the academic year. The researcher used the results of the observation to assess the correlation between studying throughout the academic year and shopping for gifts. The researcher concluded there was poor equivalency reliability between the two actions. In other words, studying was not a reliable predictor of shopping for gifts. Stability reliability. Stability reliability, also called test-retest reliability, is the agreement of measuring instruments over time. To determine stability, a measure or test is repeated on the same subjects at a future date. Results are compared and correlated with the initial test to give a measure of stability. An example of stability reliability would be the method of maintaining weights used by the US Bureau of Standards. Platinum objects of fixed weight are kept locked away. Once a year, they are taken out and weighed, allowing scales to be reset so they are weighing accurately. Keeping track of how much the scales are off from year to year establishes a stability reliability for these instruments. In this instance, the platinum weights themselves are assumed to have a perfectly fixed stability reliability. Internal consistency. Internal consistency is the extent to which tests or procedures assess the same characteristic, skill or quality. It is a measure of the precision between the observers or of the measuring instruments used in a study. This type of reliability often helps researchers interpret data and predict the value of scores and the limits of the relationship among variables. For example, a researcher designs a questionnaire to find out college students' dissatisfaction with a particular textbook. Analyzing the internal consistency of the survey items dealing with dissatisfaction will reveal the extent to which items on the questionnaire focus on the notion of dissatisfaction. Inter-rater reliability. Inter-rater reliability is the extent to which two or more individuals, that is coders or raters, agree. Inter-rater reliability addresses the consistency of the implementation of a rating system. A test of inter-rater reliability would be two or more researchers are observing a high school classroom. The class is discussing a movie that they have just viewed as a group. The researchers have a sliding rating scale, that is 1 being most positive, 5 being most negative, with which they are rating the students' oral responses. Inter-rater reliability assesses the consistency of how the rating system is implemented. For example, if one researcher gives 1 to a student response, while another researcher gives a 5, obviously the inter-rater reliability would be inconsistent. Inter-rater reliability is dependent upon the ability of two or more individuals to be consistent. Training, education and monitoring skills can enhance inter-rater reliability. Summary. Validity and reliability are the two most important issues of measurement quality. These two issues should be well thought through before a concept or variable is proposed, used, data being gathered and results analyzed. Validity refers to whether the measurement or variables really measures what we intend to measure. In other words, it refers to the extent to which an empirical measure adequately reflects the real meaning of the concept under consideration. In cases where the measurement involves no higher level of abstraction, for example, the measurements of body height and weight, validity is simple accuracy. However, validity is different from reliability. Measurements that are reliable may not necessarily be valid and vice versa. There are different types of validity. Face validity is concerned with how a measure or procedure appears. Criterion related or predictive validity. Criterion related validity, also referred to as instrumental validity, is used to demonstrate the accuracy of a measure or procedure by comparing it with another measure or procedure which has been demonstrated to be valid. Construct validity. It seeks agreement between a theoretical concept and a specific measuring device or procedure. Content validity is based on the extent to which a measurement reflects the specific intended domain of content. Reliability refers to the consistency of a number of measurements taken using the same measurement method on the same subject. If repeated measurements are highly consistent or even identical, then there is a high degree of reliability with the measurement method or the operational definition. If the variation among the repeated measurements are large, then reliability is low. There are different types of reliability. Equivalency reliability. Equivalency reliability is the extent to which two items measure identical concepts at an identical level of difficulty. Stability reliability. Stability reliability is the agreement of measuring instruments over time. Internal consistency is the extent to which tests or procedures assess the same characteristic, skill or quality. Inter-rater reliability is the extent to which two or more individuals, that is the coders or raters, agree. Inter-rater reliability addresses the consistency of the implementation of a rating system.